Hello everyone, welcome back to the course on cryptography and network security. In this session, we try to understand how the SDS algorithm is going to be processing the encryption and also how we are going to be generating the keys from the original 10-bit of key. In this session, we try to understand the key generation process. So the numerical problems we try to solve by making use of the key generation process, and also we try to solve one problem on encryption process using the SDS. So at the end of this session, the students will be able to explain the SDS key generation process using the permutation and the left shifts and generating the subkeys K1 and K2 from the original 10-bit key step by step, and they're going to be apply SDS encryption operations including initial permutation, expansion, XOR operation, SBox, substitution boxes, permutation 4-bit, and swapping, performing roundwise computation, that is FK function, using the given subkeys. At the end, compute the final ciphertext from the given plain text using SDS. In the previous session, we learned about the theoretical concepts involved in SDS. So now we try to solve numerical problems. So first step, we try to go with respect to generating the two subkeys from the original 10 bits of key. So here we are going to be in the very first step. We try to understand this is the original key we are going to be using of size 10 bit 1010000010. So I'll be going to give the numbers for each bit which is available in the given original key, like 1, 2, 3, 4, 5, 6, 7, 8, 9, the last bit is 10. So when I assign the numbers from 1 to 10, so I'll be go on permuting, so replacing the position of the bits based on the P10. So now when I'm going to be rearranging, the third bit comes as first one, and fifth bit is going to be, fifth bit is 0 here, so it will come and occupy the second position. Similarly, the second position value, that is 0, the 0 will come to the third position. So likewise, so all the numbers will be get arranged with respect to P10. So once we completed the very first step, permuting 10 bits, so I'll be going dividing that entire 10 bit into two equal halves. So 1 0 0 0, I'll be splitting, and I'm going to be calling this as left side bits, and this I'm going to be called as right side bits. So even in the case of the block diagram, we can able to understand, so whatever the 10 bit is there, that 10 bit is going to be passing to the permutation 10 bits. After permuting 10 bits, I'll be divided that into 5 bits left side and right side values. So once I split that in the second step, so I'll be go on performing both the bits. So I'll be go on shifting towards left side the whole 10 bits. So it becomes, so how it becomes, so 1 0 0 0 0. If I want to be shifting towards the left side, so it will become like this. So the output of this 0 0 0 0 1. Similarly, this one, that is the right side one, so I'll be going writing 0 1 1 0 0. So I'll be performing left shift. So what will happen? 1 1 0 0 0. So after performing the left shift by one bit, so I'm able to get these two values. Then, so those 10 bits I'll be go on performing permuting P8. That means, so all these values, so I'll be just go on writing those values 0 0 0 0 1, then 1 1 0 0 0 0. So if I give the number as 1 2 3 4 5 6 7 8 1 bit. Yeah, 8, 9 and 10. So I go with only the 8 bits. So here I'm going to be selecting only the 6th bit, 3rd bit, 7th one. That is 6th bit is 1, 3rd bit is 0, 7th bit is 1, 4th bit is 0, 8th bit is 0, and 5th bit is 1, 10th bit is 0, and the 9th bit is 0. So I'm going to be choosing, this is the number from applying the 4th step by P8. So this value will become K1. So the very first step, after first round, I'll be able to get the first key. Then, so again, whatever the values are there, that is after the first time left shift operation, that is 0, 0, 0, 1 and 0, 1 minute, 0, 0, 1, 1, 1, 0, 0, 1, 1, 0, 0. So this is again I will be gone performing 1 bit. So 0, 0, 0, 1, 0, then 1, 0, sorry, 1, 0, 0, 1. So this is what we are going to be getting it. So after the left shift the first time, so whatever we have done it here, this value, so the left shift operation after performing it, so that is 0, 0, 1, 1 and all, so that I'll be able to get back the value in the next round. So one more bit, so when I perform that, I'll be able to get back. So this is the output that I'm going to be considered as K2. So this is how I'll be go on generating the two subkeys from the original key K. So I hope you understood the way of generating the two keys. Now, so after generating the two subkeys, the next step is, so we have to go for performing the encryption operation. So the very first step is the initial permutation. So in the initial permutation, so whatever the plain text is there, this is the plain text we are going to be considering, and these are the key value which we are going to be consider as K1 and K2. So I'll be go on giving the numbers 1, 2, 3, 4, 5, 6, 7, 8. So these numbers will be rearranged with respect to initial permutation. So after the initial permutation, so I'll be able to get, this is the plain text value. So now again I'll be go on splitting this. After the initial permutation, I'll be split that 8 bit into left side and the right side. So in the block diagram, we can able to see here the very first 8 bit plain text will undergo initial permutation, then afterwards splitting into two equal half, the right side half. So whatever we are going to be called the right side half, I'll be using to expand that values into 8 bits. So again, so here I'll be writing the numbers to 1, 2, 3, 4. So these numbers will be get rearranged with respect to expanded permutation. So that, so 1101 will become the new value as 11010111. So in the block diagram also we'll be able to see that after the initial permutation, so the left side and the right side I'm passing into the expanded permutation. From that 8 bit I'll be passing into the XOR function. In the next step, I'll be performing this 8 bit expanded permuted value with K1. So the very first subkey we are going to be using to perform the that is XOR operation. So here I'll be performing, this is our expanded permutate right bit values, and this is our K1. So I'll be performing the XOR operation. So once I perform the XOR operation, so I'll be go on selecting the P4, the permutation 4 bits. So before that, I'll be submitting these values. So whatever after the XOR operation I'm getting, so I'll be splitting into two halves. So that is S0 and S1. So I'm going to be replacing the values of these 8 bits into 4 bit by substituting in the substitution box. So now, so in the case of here, the left side value 0, 1, 0, 0. So the first bit, this is first bit and fourth bit. The first and fourth bit I'm going to be used to represent row, and the second bit and third bit use it to represent column in the substitution box. So the first bit and the fourth bit is 0, 0. Second bit and the third bit is 1, 0. So in binary to decimal, if I convert, so this becomes 2 and this becomes 0. So 0th row and second column, so I'm going to be choosing it. See here, 0th row, second column, that is value is 1, 1. Okay. So now I'm going to be get the value. So here similarly I'll be going choosing this the right side value. So first bit and the fourth bit I'm going to be use it to represent the row, and the middle 2 bits I'm going to be use it to represent column. So in this case 1, 1, 3, 3 is there. So 3 and 3, the value will become 3. So this is how we'll be able to get the values replacing of step 4. So from this step I'll be go for choosing, see here the result will be 1, 1, 1, 0. So that is 3 from one substitution box and 2 from the another substitution box. So after performing the P4, I'll be able to get 1, 1, 1, 0. Now I'll be performing the XOR with the left. See here in the block diagram, after the substitution box we got P4 bit, those 4 bits and the left side, the initial left side value what we have. So okay, so initially we divided into 2 equal, right? So that equal values will be performing the XOR operation. So now I'll be able to get 0, 1, 0, 1 after the XOR operation. Now it remains in the left side and the right side value. So that right side value is again from the beginning. So this is the initial right side value. So I'm just swapping it. So after swapping, I'm able to get the left side is 1, 1, 0, 1 and the right side value is 0, 1, 0, 1. So this is will become an input to the next round. So again I'll be on splitting into left and right. So I'll be passing into the expanded permutation the right side value. See here the second rounds. In the second round the same thing, I'll be go on right side value will be expanded to the expanded permutation. Then I'll be performing with K2. So then the output what I'm going to be getting splitting into left side half and the right side half. So that left side I'm going to be given to the S0, the right side value I'm going to be given to the S1. So I'm just go on replacing the values which is available in the S0 and S1 substitution box. Then I'll be able to apply the permutation P4 bit. So finally I got the answer 1011. Once I got an output 1011, that I'm going to be retaining as it is, and the right side initial right side value here, this one I'm going to be taking. So here at this stage there is no kind of swapping and all, so we have to be going to apply the inverse initial permutation. So that is here the permutation that is we call as initial permutation. So finally I'm able to get the ciphertext for the given plain text. So plain text was taken as 1101 0111 and the ciphertext I got is 1010 1000. So by looking at the steps which is available in the block diagram, so we have divided into two rounds. The first round we use the K1 and in the case of second round we are going to be using the K2. So with this we are going to be ending today's session. So that is SDS key generation produces the two subkeys K1 and K2 by using permutations and left shift. And so we are going to be apply the encryption process by making use of initial permutation values and the two rounds of function f with K1 and K2, the swap operation and the final permutation. So in the next session we try to understand about how the next symmetric algorithm, that is AES algorithm, is going to be performing its various rounds, and we try to understand the process of encryption and decryption. With this note, we are ending today's session. Thank you.